Okay, this is DC circuit analysis, and we're going to cover section 4.7, ground connections, 4.8, computer analysis, and 4.9, applications today. And I believe that I gave everyone the solutions, and we went over in class all the way up to 31. And then I did some of the voltage divider problems on the board last week. And then I assigned homework problems from section 4.8, computer analysis, and 4.9, applications. And today I'm going to go over some of the computer analysis. Specifically, we've already went over Multisim, and everyone should have a copy of that for your computer and a student version that you purchased. And today we're going to go over OrCad. So if you want to bring up your computers and bring up the icon that looks like this while I take roll, go ahead and get this up and running. If you double click on it, it should say, do you want to run this in administrator mode? And yes, you do want to. And that's another thing. If you download this, you have to, if you download this for your computer at home, you have to right click on it and say either run as administrator. If you don't, it's not going to work right. Or you go to properties and you go to compatibility and you click run this program as administrator. Then it will always run as administrator. Running as administrator gives you rights to write to special folders like program files and things like that, which they try to protect those folders from people who, really from people who don't really know how to use computers. They try to prevent people from messing up with those areas. So that's considered administrative rights. In order to get this program to work in this lab, I had to request from IT that all these computers have administrator rights on them, which took some doing, but I finally got it to work. So, when I call your name, come and show me your homework. And I was wanting you guys to do, for the computer applications part, I specifically wanted you to use a computer program to do those problems. Now, if you didn't, then after we do the tutorial today, then you'll have another opportunity to do those. Yeah.
Could we do that on Multisim?
Yeah, Multisim. Either one. I'll show you the other one today, and it's your option on which one you want to use. There's some advantages of using both. Some have advantages, and some disadvantages. It depends on your own personal preference on which one you prefer. But I want you to at least know both of them up to a basic level. Gary? What's that? The computer's not coming up? Maybe the keyboard's not connected. I would reboot it. Huh? Just reboot it. Oh, say welcome.
Just goes over, continues forever.
How long has it been doing that?
Probably 5 minutes.
Oh, do Control Alternate Delete. It's probably looking for the network. If the network's down today, that could be it.
Not responding.
Try that one.
Yeah, so I get right in there.
Yours is up. It just asks a bunch of questions. Just keep saying yes. It asks a bunch of questions. I don't know why, but basically because you're using the free version, you're supposed to have a license, but it's really expensive, so I'm not going to mess around with trying to get a license for that. 1014. Are you kidding me? 1014. Da, da, da.
We're supposed to be opening this with Cadence?
Mm-hmm.
Okay.
Yeah, use this one, OrCad capture. Okay, Corey. Go to 63. Did you use any sort of multisim or anything? You didn't? No. Okay. Can you try to do that next time? Dakota. Okay. And you already said you wanted 63.
Yes, go over if you don't mind.
Did you use any sort of CAD software?
Nah, computer crashed.
Oh, computer crash.
So
okay.
I'm gonna reboot it, and I'll do it in here today, but
okay.
I'll get it done.
Are you gonna get your computer back working, or is it dead?
Nah, well, I had the blue screen of death. You gotta take it and have it wiped and then reboot it.
Oh, okay. Jesse?
Here, I haven't got home.
No homework. And Christopher?
Take your time.
Oh, I shall. There's the homework from last week. I went ahead and did it because I didn't have it ready. And then this is the homework for due today.
Okay, so you did last week? Okay, I'll give you half
I did
credit for
both.
that. Let's see. Did you use any of the software to do any of those?
For 59, I tried to use the Multisim, but I didn't know where to pull up the spice on it, where it was asking for on the different nodes, so I ended up just doing it with KVL instead.
You didn't know where to get the multimeters or the display, like current and voltage displays?
I could do the little multimeter tool they have on there, but it would only let me use the multimeter while I'm simulating. So there's some of the stuff I couldn't measure. It was all nominal.
Oh, okay. You couldn't do the min and the max? No. Frederick?
I don't have my
You don't have yours? Okay.
I've been in the hospital. My mom's bleeding. She had a stroke.
Oh, sorry about that.
I probably won't be at the next class.
Oh, okay.
They just got them running her through MRI.
You're going to be in the hospital?
Yes, sir.
Okay. Oh yeah, and I may be out this week too. Because I have two daughters that have temperatures of like 103, so I'm going to probably have to give you guys some assignments, and you'll work on them during class. I may have some proctors this week, but I'll make sure you guys have something to do. Okay.
Sorry to hear about that, Doc.
Yeah.
They have the flu?
I don't know. This is just a fever. Just really high fever. You know, they've been throwing up. So.
That sounds like the flu.
After they get that far, it's nothing they can do.
Gary. Yeah, probably for. Of course, today we have fabs, so that'll be good. We'll get that done. And
I don't have this. Last week's gonna have this on.
oh yeah, okay, that's last week.
I thought I had Multisim. I don't have it.
Okay, most of these problems are just hand problems. Yeah, but do you have any? You don't have a computer?
I don't have the software. Multisim.
You don't have any software?
Multisim. P-Spice.
You have Multisim?
I don't.
You don't have Multisim, but you have P-Spice. You can download Multisim for free, and you can get a 30-day license. All you can do is go to the website. Even without a code, you can download it. And I can give you a code to put in there if you want one. Actually, to be honest, you can use anyone's code in here to put in there.
Yeah, they're all the same.
No, they're all different, but it's not going to knock you out. Like if you put in the code twice, it's not going to knock you out. It's not like it takes the code and then says, okay, well, you can't use it over here. It's not like that. So if I was you, I would just download it, Gary, and just use someone else's code. I mean, it's fine. It's the, and now we have Donald. Don.
I didn't use the software.
Okay. All right. Clarence. Another motivation for using the software is to check your work and to make sure that sometimes you get a wrong answer. Server's down? So no one's computer's working? Okay.
The software stuff.
Oh, good, good. Good. You're the only one that did the computer software. Okay. All right. Thanks. So out of the problems 47 through 51, let's just work a couple of those in class. I'll let you guys pick. I'm going to have to put a limit on just maybe 2 because the rest of them I'll post on Moodle, and then we need to go into like a little tutorial for Multisim, for PSpice. So I think Dakota already said, what, 63 or something like that? Okay.
Gord.
Oh, okay. Server's not down. That's good. 63. Says figure 4.7. Figure 4.7 has a resistor and a 12-volt battery. .7 ohm resistor labeled RL. 0.1 ohm RI, it says. 12-volt battery. And with the dotted line, it's trying to say that this is a model for some, this is really saying that this is like a black box, you could call it, or a component. And inside of that component, it's modeling the internal structure of that component. In this case, a battery that has an internal resistance. So that's what the dotted line means. Okay, it shows a circuit consisting of a lamp with a resistance of 11.7 ohms. So the lamp is being modeled actually by a resistor. So RL for our lamp. And a battery with internal resistance. So this is modeling the battery. It says find A. The part A of this one is to find the current drawn from the battery. So the current's going to be drawn out of the battery. It's going to come out of the positive terminal. So we're going to call this I. You could label it here if you want to, I, wherever you want to put it, coming out of the battery. So we'll just say find I. Find I. Okay. So how are we going to do this one?
Total resistance, which means internal and external.
Well, okay. Yeah, you could do total. You could do total, or you could do KVL. What would you do if you did R total? RT equals what? 12 ohms, yeah. 0.3 ohms plus 11.7 ohms equals 12 ohms. So you can find the total, and then you can combine all these resistors in this one and then have the battery there. And then you can say, you can use Ohm's law to say, well, I is equal to V over R total equals 12 volts over 12 ohms equals 1 amps. So that's part A. Part B is, now another way, let me just show another way to do that problem is just to use KVL. You could, if you wanted to do KVL, you could say minus 12, going this way, what's the voltage drop there? Be I times R plus I times R, and then keep going around, just assign the correct polarities, plus I times R, where this is actually Rn, this is R, what, L. And then you can say equals to 0. You move the 12 to the other side of the equation, it's going to give you IRN plus IRL equals 12. Then you collect the I terms, it gives you RI plus RL equals 12. And then you can say I is equal to 12 over RI plus RL. And I really want to throw that pen away because I don't like that pen. Okay. Okay, so either one gives you the right answer, right? KVL is the more general. KVL, you can use it to solve any type of problem. So part B says, the voltage drop across the internal resistance Ri. Okay, well, how are we going to determine the voltage drop across Ri?
Found out the amperage.
Yeah, it's 1 amps. Notice the amperage. Is it positive or negative? Positive, which means the current is actually flowing this direction in the same direction as the reference current, which means that what's the polarity of the voltage drop? Is this side going to be higher or is this side going to be higher in voltage? This side, the right side, is going to be higher because we assigned it positive when we did KVL. And that's a pitfall. One of the pitfalls of using combining the resistors is you still have to make sure you choose the right polarities. If you use KVL, it'll make sure you have the right polarities. You know, of course, if you use the combination where you combine the two resistors, you can still use that, but you just make sure you use the passive sign convention. Passive sign convention. And then when you do your formula, you'll know which Ohm's law to use. Because if you use the passive sign convention, you can use the regular Ohm's law without the minus. But if you don't use the passive sign convention, you'll have to use the Ohm's law with the minus in the equation. So, what is the voltage drop? It's going to be V is equal to I times R. R, in this case, is actually Ri. The current is actually this current, 1 amp. And the V is, we could just call it V, whatever you want to call it, VI. I guess this is Ri, we can call that VI. We'll keep the little subscripts together. And so that will give us 1 times 0.3 equals 0.3 volts. So the voltage, the internal voltage across inside of the battery is going to be 0.3. So what is the total voltage going to be across the terminals of the battery? This is
11.7.
Yeah, 11.7. I don't know if they're going to ask that, but that's what I would ask.
Yeah, it does.
Okay. Now, the C, the power dissipated by the load. Okay, C.
That was C. C is the terminal voltage of the battery.
C is the terminal voltage of the battery.
Oh, I'm sorry. I went to the wrong one. C. I was up to 62. Yes. the terminal voltage of the battery. So we would call the terminal voltage of the battery, we could label it maybe 1, 2. So we could say, what is V2 to 1? So what is the voltage from terminal 2 to terminal 1, which I'm going to call V21, with this being in the plus direction. V21 is going to be what? Yeah.
You go 2 to 1, it should be negative.
Using KVL, I'm going to call this V2 to 1. Right? I'm calling this plus, this one minus. So that means if I do KVL, it's going to say, I'm going to go through this minus. So I've got minus V21. I go through this. And then I'm going to get minus VI, right? Which I already know that one. And then I'm going to get it plus 12 equals 0. So now if I move the minus V21 to the other side, then I get V21 equals 12 minus VI is 12 minus 0.3 equals 11.7 volts. Now, you can just look at this and tell, but if you can't look at it, then you can always use KVL. Part D says, the power dissipated internally by the battery. The power dissipated in the battery is going to be only due to the resistance. Only resistors dissipate power. Capacitors do not dissipate power. Capacitors store energy. And inductors do not dissipate power. They store energy. Inductors store energy in the form of magnetic field. Capacitors store energy in the form of electrons, or electric field, you could call it. Resistors do not store energy. So the only thing in this circuit that can dissipate, in this battery that could dissipate energy would be the resistor. So what is the equation for power through a resistor? There's 3 equations.
One is voltage times amperage.
Power is equal to V times I, V squared over R, and I squared R. What's the best one to use in this case? VI or V squared R. But yeah, VI in this case would work because we already have both of those. So let's just use P is equal to VI. So the voltage is what?
12.
0.3. We said that VI was 0.3. So we're going to do 0.3 and then the current is 1. So that the power is going to be 0.3 and the units is what? Watts. Yeah. And watts is joules per second. So it's energy per second. So it's how quickly energy is being dissipated. Now let's do part, is there a part E, I think?
There's an E.
Oh, and there's an E and an F. Okay, there's a lot of parts on this one. Part E, the power delivered to the load. Okay, again, the same thing. The power delivered to the load, since the load is a resistor, we're going to use the power equation. P is equal to what? VI equals V squared over R equals I squared R. In this case, I would prefer to use I squared R only because I know what the current is and I know it's 1. So it's so simple to use I squared R. P is equal to I squared, 1 squared is, and then R is going to be 11.7. So 1 squared obviously is 1 times 11.7 gives you a power of 11.7. What's the units? Watts. Yeah. Watts. And for watts, we do a W with 2 lines on top of it. That's the best way to do the watts unit. F. Part F. The efficiency of the battery. Okay. Well, efficiency is typically, it's always, well, efficiency, sorry, I drew the wrong symbol. Efficiency, we use this symbol called mu for efficiency, equals efficiency. Yeah, we use a micro symbol for efficiency. We try to use all the Greek characters, and we use them multiple times. So, but in this case, micro is used as a variable, not as a what? Multiplier. So, using it as a variable. Efficiency equals always, efficiency is P out over P in. So efficiency is defined as you're putting in a certain amount of power, you're getting out a certain amount of power. For example, let's say you're putting 10 watts of energy into a system, into a black box. You don't really care what it is. It goes into a room, a line in goes in, and you have a line coming out. And you say, you're putting in 10 watts. And you know that you're getting 9 watts out of the system, actually doing useful work. We would say that the efficiency of that system would be what? 90%. 90%. You're putting in 10, you're getting out 9. 90%. Okay, in this case, we're putting in how much?
In 12.
So we're going to say Pn is going to be Vn times In. And P out is going to be V out times I out. Okay, that's a simple way to do it. Okay, now, since this is a series circuit, what are the I's going to be? They're both going to be 1. And it doesn't really matter what the value is, because since it's in a series circuit, they're going to cancel anyway, right? So really, in this circuit, the power is going to be V out over V in. So what is the voltage on the output?
11.7.
11.7 volts. Does everyone understand that?
12.
11.7. And then this is going to be 12. Why? Well, we know 1 amp's flowing through here, so we know that that's 11.7 ohms, because V is equal to I times R, Ohm's law. So we know that the voltage across this is 11.7 volts. We know that the voltage we're putting in the system is 12. So we wind up with this 11.7 divided by 12. 97.5. Now notice that here you have a volt and a volt, so you're dividing the volt to the volt. So what you wind up with is what? A dimensionless number. A number that has no dimension. Anytime you have a number that has no dimension, you always have either what we call a ratio or a percentage. In this case, we convert it to percent. What we wind up with is 0.975, which is a number that's always going to be less than 1 if you do it right. Anything from 0 to 1. And you multiply by 100 to convert it to percentage. And typically, for a dimensionless number, we'll convert it to percentage. The same thing applies for duty cycle. You always wind up with a dimensionless number, and usually that duty cycle is in a percentage. You specify in a percentage. Yeah?
Just out of curiosity, where would you come up with 12 volts?
The 12 volts is the power you're putting into the system, and so that's the power in this case is going to be 12 volts times 1 amp gives you 12 watts. So 12 watts is the input power to the system.
Is that just a calculated number?
Yeah, it's the rated voltage.
You could never measure that because it would actually be 11.7.
Well, how would you measure the 12 internal resistance? How could you measure that? What if you did this? What would the current be through here during zero current? 0, which means the voltage drop would be across the resistor. Would be, oh, wow, that was cool. 0. If there's 0 amps flowing through the resistor, there's 0 voltage drop. That means that this connection and this connection will be the same. So this would be 12 volts and this would be 12 volts. So the no load voltage on a battery is the internal battery voltage.
Would you be able to measure that with a meter at 12 volts?
Yeah.
As soon as you disconnect it from the
Get
circuit.
another resistance.
Yeah, let's say you take a battery, car battery.
Circuit, aren't you, with the meter?
Yeah, if you take a car battery and nothing's on, you measure that battery voltage. That's the internal voltage in the battery. As soon as you start to load it, the voltage is going to start to drop. So, yeah, and it's the internal resistance of that battery is actually the electrolyte, the what do you call it? Sulfuric acid, mostly. So, okay, well, that's all we really have time to work. I'll put the rest of the solutions on Moodle, and you guys can ask me questions if you have any questions about that. We'll do a quick tutorial. Okay. Now, in the back of your book, I know it's dark now, but in the back of your book, you have a really, really nice tutorial on both Multisim and PSpice. It's actually in Appendix C. You have a very detailed, very nice tutorial. And actually, what I want you guys to work on for next class is going to be this tutorial, and I'll give you that homework assignment at the end of class. And I also want you to work on, if you didn't use Multisim or PSpice on one of your homework problems, I'm going to ask that you do that again too. But the first thing we do in order to get the PSpice to run is, like I said, right-click on it, say Run as Administrator. In this case, I already have it running. Okay, so now I'm going to do File, New. But before I do that, let me just show you really quickly that there's other tutorials for this as well. If you go to the folder, a little bit of introductory on PSpice. This is under a company called Cadence, is one of the largest EDA tool vendors in the United States, in the world probably, Cadence. And PSpice was originally designed by a small company in the 90s by Microsim. And they gave it away for free at all the colleges and universities, and it was had a very nice interface. Worked very well. And this is the program that I was raised on when I went to school, PSpice. Subsequently, anytime a company invests in education, it always pays off, but it takes time to pay off. Eventually it became the largest, the best, basically it became the industry standard. A small little no-name company that was giving it away for free. It got so big that the big company, Cadence, they bought it, of course. They said, we want this. They bought it and they hacked it all up and messed it up, and we have it the way that it is today, but it's still a good, it's industry standard. That's the problem with it. It's not as easy to use as Multisim. There's some little bit of things you have to do in order to get it to work. But everyone who makes components, they always give PSpice models. So anyone that makes a resistor, capacitor, a switching regulator, whatever, they'll design it and then they'll say, okay, well, we've got to make a PSpice model, because if we don't, everyone's going to be asking for a PSpice model. So that's kind of where we're at. Multisim is starting to become popular, and probably someday, if not already, maybe starting to overcome PSpice, because Cadence really bought PSpice just because it was competition to them and they wanted to have it. And also it's industry standard. And they try to make their own software and make it industry standard, but they can't really do it. Because really in the end, it's the consumer who decides what's going to be popular. So that's kind of the way we are. We're just at that place. Multisim is a company it's called National Instruments, and they traditionally make data acquisition and testing automation software. For example, National Instruments, they have a graphical software where you can connect all your oscilloscopes, your power supplies. You can connect it to a USB on your computer, and you can automate. You can create tests that automate your instruments. In other words, it'll turn on your DMM, it'll capture current, voltage, whatever. It'll turn on your scope, and it'll capture images, and it can test a system on its own. You can go to lunch, come back, and the test is done. But National Instruments got into electronics workbench in the 90s as well, and they were giving away for free. They were trying to get people to buy it. Eventually, it became what we know today as Multisim. The great thing about Multisim, it's very interactive. It's easy to use. They have a lot of. It's very graphical, and really simple to use. If you go, so a lot of times people install PSpice and they say, well, I can't find PSpice, and that's because it's under the category of Cadence. And the same thing is true with Multisim. All the manufacturers, they love to put their product under the actual name of their company. So you'll find Multisim under National Instruments, and you'll find PSpice under Cadence. Okay. So if you go under Cadence, you find OrCad Capture CIS demo, and the demo is just because it's the free version that they allow you to have. You can also go to Cadence Help, and you got some accessories down here that you can tour. You also have the Help menu. You also have documentation. You have Learning OrCad CIS Capture. So if you go to the documentation, you can have a user's guide, you can have a quick reference guide, you can click on this tutorial, okay, OrCad flow tutorial. So there's several tools that you can go to there if you want more information. And you can also go to YouTube, and there's also some lessons here if you go to that part, say lesson menu, and you can click and do these exercises. I went through these and I didn't really like them. What I found to be the most helpful was just go to YouTube and say OrCad tutorial. And there's some really nice tutorials out there. So what we're going to do is we're going to work on the first one in the book on page 4.8. Computer analysis. Page 75, it says, use PSpice to find the node voltages in the circuit of figure 428. Determine the current. So the first thing we're going to do, we pull up OrCad, we say File. First we have to create a project. Okay. So we say File, New, and then we're going to do Project. Now in the name you can say, we're going to do example 4.8. Example 4. I use a P instead of a point because some programs don't like when you use a point in your name. So I just say 4P8. Okay, and I'm going to do analog or mixed AD. You can also do a PCB board. They have software that will design a printed circuit board for fabrication. And you can do a schematic that's just used for generic schematic purposes. Down here you can say the location. You can decide where you want to put it. So I'm going to change that. Well, it's going to put it in my documents and then in PSpice. So that's okay. But make sure you put it, if you want to put it on your flash drive, you can come down here and change it to your flash drive. Okay? In fact, probably the best thing to do would be to put it in a directory that's suited for your application. In this case, the best application for me would be to put it in Dropbox, find the class, DC circuit analysis, And then I can put it in my simulation files. Okay?
Just almost there, is there any way we can do this and send it to ourselves?
Yeah, you can send it to yourself. So I'm going to put it in simulation files in my DC circuits folder. And I would suggest you create something similar on your flash drive. You can have simulation files or inside of your ELC 138 folder. And say OK. And then it's going to ask you to either create a blank project or one that has a ground symbol in it. And we're just going to go ahead and use the one that says the default one. Say OK.
It's not giving me my drive, my E drive. All it gives is document.
When did it may take a while for it to recognize it. When did you put it in?
I looked this up as soon as I started.
Oh, okay.
License was not found.
Now it's going to ask you a bunch of questions. You guys can watch me, and then we'll go through the.
Yeah, that sounds,
I'll help you in class after. This is watch me for now.
all right, good deal. I can do that.
The demo edition does not only has support for 15 parts. You can just keep saying OK. Okay. Now what it comes up with is a little file management utility to the left. We can click the plus arrow and you can see that there's a schematic under there. And it has a page 1 that's already been created for you. Now this is one of the features that I don't really like about PSpice. In Multisim, when you create a new schematic, it brings up a schematic page. Well, in PSpice, it doesn't. You have to open it yourself. You have to create the project, then you have to pull up the schematic. So that's a little bit annoying. But if we double click that, then it's going to pull up the schematic. Now, what we're going to do is we need to place the resistors on the screen from page 75. Oh, just watch me, and then we'll do that later. Yeah. So, if I click on the right of the screen, it says place part. You see the little part thing over here? We're going to click that. Now, at the top, you can see, you can type R. If you hit R, it's going to search around for a component that starts with R. And you can see the first thing it comes to is this R analog. And you see other ones down here as well. And if you click on that, it shows you a symbol of what it looks like. There's a potentiometer. There's some RAM. But really what we want is that first little R. We want the resistor. So in order to place the resistor, in order for it to snap to your cursor, you actually have to hit the part symbol again. See that? Then it gives you a part on your mouse and it follows you around. Now what I'm going to do is I'm going to place 3 of those resistors to make them look just like the one in the book on page 75. So click once, twice, 3 times. Now notice that I have my I have the resistor still there. Now I'm going to search for a battery. So I'm going to backspace on R. I'm going to hit V. Now the voltage source here, I don't really want that voltage source. Let me look around for a better one. So I'm going to, there's one that's better. And if you can tab down, or you can scroll down and you can see all the different parts here. But I'm going to choose the one that looks like a battery. In order to get that on my cursor, I have to hit the plus part menu button. That gives me a battery. Now I'm going to put it to the left click 1 time. And that's all the parts that I need. So in order to get rid of the extra battery, I'm going to hit escape. Now this ground symbol has a round terminal on it that I don't need. So what I'm going to do is I'm going to select that ground. That's actually a terminal, and I'm just going to hit delete. I'm going to leave the ground symbol on the screen because in order to do a schematic, you have to have at least 1 ground. But now I need to wire these up all in series. So what I'm going to do is I'm going to hit my wire tool. The one at the very top left, it says place wire. Or you can hit, I believe you can hit W. well, maybe you can't hit W. Place wire W. So I click that. Once you click it, then it depresses that button. And what you can do is left click, and then left click, and then you're done. Wire up the components, left click on each one. Now, if you left click on the last one, you notice that it's just going to follow you around. So in this case, I'm going to put it where I want it to be. Left click again, that secures it in this location. And then I'm going to secure it here by left clicking, and then left click there to end it. Oops. Now I'm going to go ahead and connect my ground symbol. Now I can click my select tool, and when I click on the screen, notice that it puts a little dot there, a connection point. So now we have a complete schematic. The only problem we have is now this says 0 volts. We want to change the 0 volts to 100 according to the schematic on page 75 in your book. So we're going to type in 100. You can have it display the value, the name, different things. So now it says 100. But now the only problem we have is these resistor values aren't correct. So if you click on the resistor value, you have to be very careful. If you click on the entire part, it pulls up this menu that looks like this, and you can scroll through it, and there's lots of information up there, way too much information. And if you want to close this out, then you can hit the little X up here, I believe.
Right.
So let me do that again. Hit the part. It brings up that. You can put the nominal, you can put in the resistor value. Let's see if we can find it. There it is, right there. The value. You can put in temperature coefficients. You can put in a lot of things. You can change the value right here in this spot to 25 ohms, and then hit enter. And then you can hit the little X at the top of the screen, and it'll close that form out. Now you have a value of 25. Now let me show you an easier way to do that. This one needs to be a value of 10 ohms, not 1K. So if you just click the value and not the component, you have to be careful. Hover over the value and double click. It's going to give you a simpler box. In this case, I'm going to enter 10 and click OK. So you have to be very, very accurate with your mouse. Now, before we continue on, I'm going to notice how I have a lot of white space on the screen. I want to zoom into just this area so it would be easier to see. So what I can use is the zoom to all on the top of the screen. If I click that, it zooms the whole page. And you can see you have a document title that you can put in. But I don't really want that. I want to zoom to a certain region, so I can click that one. I can highlight just the region that I want. And now it blows it up bigger so you can see it.
Should hit zoom first and go down and do that?
Yeah. Now notice that I still have the zoom feature on. I'm going to hit escape. Escape gets me out of that. Or you can alternately, you can come over here and you can click the little select tool. Now the last thing I'm going to do is I'm going to change this R3 into a 15 ohm resistor. Now I'm ready to do a simulation. Let's hit the save button. Okay. Now my goal of entering the schematic is I want to find the voltages on each node in the circuit. In order to do that, I have to create a simulation profile. Now in Multisim, all you'd have to do is hit the run button, right? But this is PSpice, and they wanted to make it a little bit more difficult. Okay? But there's an advantage here, and I'll show you what the advantage is in a minute. It's easy to do this, though, because think about the run button. There's 2 buttons to the left of it, right? You have to go through each one in order to get to the run button, left to right. So we want it to be at the run button, but first we have to set up what? A new simulation profile. Call it anything you want. We can call it DC, because we're just going to do a DC analysis. You can do transient, AC, whatever. And really the name you put here doesn't matter at all. It's just a reference name. So I'll just put DC bias, put it whatever you want. Now, when you do that, it's going to start blinking down here, and you have to click that in order to get this form to pop up. Okay, so this form will pop up, and it has all different types of analysis in here. If you look at this analysis type, it says time domain transient. If you click this, you get a DC, you get AC, bias point. For right now, we can just do bias point. Bias point is the most basic. What that does is it gives you basically your KVL. It tells you the voltages and the currents in the circuit, the DC level. And that's all it does. Now, you can hit save again, just to be sure that you save your information. Now you can hit the run button because you did the first one. The first one is the new simulation profile creates the DC bias simulation profile. The next box over brings you back to your little GUI. We call this a GUI, graphical user interface, which allows you to change your settings. So you've already done one, you created the new one, you changed the settings, and now you're going to run it. Now it's going to pop up this little box down here, it's going to be bleeping. Okay. Now typically this is where you would graph things. Now, in this case we don't really want to graph anything. But if you had a waveform, if you had a duty cycle, or you had a rise time of a capacitor, you could plot that on this screen. But right now we just want the voltages and the currents. So the simulation is done, okay? But how do we view the voltages? Well, in order to view the voltages, you can turn on, notice if you hover your mouse over this, it says Enable Bias Voltage Display. This is the cool thing about PSpice that Multisim does not provide. And I don't know why Multisim doesn't provide it, because it would be really great if they did. The cool thing is you don't have to put a bunch of voltage meters or current meters in here. All you have to do is click that button. You can have the most complicated schematic in the world. It'll show you the voltage on every single node in that schematic. And you can click current. It'll show you the current through each component. And you can even move those around if you want. And you can hit watts, will give you the power through each component. Multisim does not do this. In Multisim, you would have to come in and you'd have to put a voltmeter or a wattmeter on every single node. So if you can get over the fact, if you can deal with the little bit of extra work involved in opening up the schematic the first time and creating the simulation profile, then PSpice is a lot better from that respect. And I think that's pretty much it. So I'm going to give you guys an opportunity to practice this. And before class is over, I'll give you guys an assignment put on the board.
So where can I download this OrCad capture program?
If you want to download Cadence OrCad Capture, I would just Google it. So let's go to Google. So I would say Cadence OrCad Cadence OrCad, I guess download maybe. And the first thing, you can just click on that one. Let's see. Capture, only thing you want really is capture in PSpice only. This one right here. If you do all products, they'll probably send you a DVD, but we don't really need the DVD. If you want to click that, they'll send you the DVD and you can install it. But I think you can go down here and you can do a download. So right here, download for free. 646 megabytes. Includes OrCAD flow tutorial with example design. Submit request to receive a hard copy of OrCAD. If you want to see the hard copy, you can just do that. And there you go.